circumference and areas of circles. So the circumference of a circle is sort of like just the perimeter of the circle, so just the outside measure. So if we look at any circle here, it's just the measure on the outside, right around there. But you can't measure it exactly because they're not straight lines. So we have to come up with a formula that's a little bit complex, or at least it seems complex, but it's actually pretty easy. All you need to do is know the amount of the radius or the diameter, and then you can figure out what the circumference is. Because there's this magic number. It's called pi. And pi is equal to the circumference over the diameter. Or alternatively, it can also be equal to, well, let's see, pi is also equal to the circumference over two radiuses, because that's two radiuses the same as one diameter. Now the Greek letter pi is just the ratio of that circumference over the diameter, or the circumference over the two radiuses. And the formula we use normally to find circumference, though, is right here. It's this one right here. Circumference is equal to pi times the diameter. Now, pi is a funky number. It's the first of what's called irrational numbers, and we'll deal with that in the next lesson. It's something that goes on forever and doesn't repeat. That's a quick summary. But pi is equal to approximately 3.14159, and it keeps on going on forever. But we're just going to use this right here. We're just going to use these three numbers here. 3.14, just as an approximation. People have spent years and years trying to figure out pi to millions of digits. It's one of the ways that they test computers, but it's really not all that relevant beyond this for our purposes. So, if you look over here, we've got a circle, and we're trying to find the circumference, and the circumference is equal to the diameter, which is 3 centimeters, times pi. So if we just plug that into the calculator, I'm holding on to right now, 3.14 times the diameter, which is going to be 3 centimeters, you're going to end up with 9.42 centimeters. Now remember, it's just going to be centimeters because we're just measuring distance, the distance around the actual circle. So that's the reason why it's just centimeters, not centimeters squared. When we get to area, we're going to deal with centimeters squared. So same thing here. If we look up here, we got a circle with a diameter of 1. So it's just going to be 1 times pi. So the circumference is just going to be 3.14 centimeters. So easy enough. All we're going to do is just keep multiplying these out. 5.2 times 3.14 is going to be equal to whatever the value is of the circumference. So 5.2 times 3.14 is equal to 16.328. And that's just again equal to the value for pi, which we use, which you can just substitute right in. If you just want to use that instead of the pi symbol, that's fine. It's fine with me. Times 5.2. That's all we're doing. We're just substituting in values here. That's meters and meters over here. So pretty simple. You just keep doing it that way. Now, if instead we have the radius, like let's imagine that we have a problem with a circle that has a radius instead of a diameter. The radius is going to be equal to, let's see here, what could the radius be equal to? Let's say the radius is going to be equal to instead, no, let's put it up here. Radius is going to be equal to 5 centimeters. So what's the diameter? It's going to be 10 centimeters. If you want to do it that way, you can do it that way. Or you could just multiply it, use this formula right here, which is circumference is equal to 2 times pi times r. it's exactly the same thing because 2 radius is equal to a diameter. But if you have the radius already and you just want to plug it in and figure it out that way, that's a simple way of doing it. So that's just going to be 20 times the value of pi, because 2 times the radius is, if the radius is 5, that's going to be 10. 10 times the value of pi is going to be 31.4. So if we have a radius of 5, and it can work this way. If you see here, if we wanted to figure out what the radius was of this, it's going to be 40 millimeters. If it's going to be, it's going to be 0.5 centimeters here. And this is going to be really important for down here, because a lot of times you're asked to figure out the area and the circumference of something, and you don't know one of them, but you need to figure it out. And you should always be able to figure out radius from a diameter and diameter from radius, because it's either multiply by 2 or divide by 2. So now the area of a circle formula is pi is equal the area is equal to pi times r squared. And we'll talk about the derivation of this formula in class and why it works that way. It's basically that you go ahead and you divide a circle up into a bunch of sectors that then you can rearrange into a parallelogram, and it ends up being this. But that's kind of a complex way of saying it. So let's just go ahead and say, well, we've got the area here is equal to pi times radius. So remember this problem up here, 5 centimeters. So we just plug it in. The area is going to be equal to pi times 5 squared. So it's going to be equal to 25 pi, which when we multiply by 3.14, 25 times 3.14 is going to give us 78.5. Now, one way of really making sure that you have this down right, though, is it's not centimeters anymore because we multiplied centimeters times centimeters, so we now have centimeters squared, just like when we multiplied 5 times 5 for this problem. We multiplied centimeters times centimeters, so we have centimeters squared as well. So this is going to be a unit of area, and area is always in centimeters squared or inches squared, whatever unit you're using, but it's squared. So that's really important to remember. Now, one thing a lot of people do when they approach these sort of problems, they look at these sort of things and they try and figure it out, and they go ahead and they say, oh, well, this over here, check that out. We got 3 centimeters. Well, the area just must be 3 times pi. And that's not right. You have to change that to a radius, which is going to be 1.5 centimeters. So remember, that's 1.5 centimeters is the radius. So it'd be 1.5 squared times pi. And then, so 1.5 times 1.5. And then times that by 3.14. You end up with 7.065. And again, one more time here, that's in centimeters squared. Very important to remember. Now over here, we have a kiwi fruit. Kiwis are okay. Not a huge fan of the kiwi, but they're okay. And if you look here, kiwis are pretty round. And if we wanted to figure out the circumference, the measure around the center of the kiwi, we would just go ahead and measure from here to here. And we would just then use our formula. And if that's, let's see here, if it's a 2-inch kiwi, so 2 inches is the measure of the diameter. Then we would just multiply that using our formula, pi times d is equal to the circumference. So we just multiply it and we'd end up with 3.14 times 2, which is equal to the circumference again. And 3.14 times 2, should be able to do this in my head, I will. So that's going to be 8, 2, And remember, we need to put that inches around there. Now, if I wanted to figure out the area of the face of this, it would be the diameter is 2 inches. Now, that means the radius is equal to what? Well, it's not equal to 2 inches. It's the radius is going to be equal to 1 inch. So I need to do now pi, the area, is going to be equal to pi times r squared. When I do that, what's r? It's going to be 1 squared times pi is equal to the area. And so it's just going to be equal to pi because 1 times 1 is 1. So the area is going to be 3.14. But remember, it's inches squared because it's a unit of area. Now, this guy here, if you think I'm obsessed with circles, this guy is obsessed with circles. And this guy right here, the One Ring from Lord of the Rings, this would be Gollum. He's got some major league problems. But if you look here, the thing that always was most interesting to me about that ring was that it would change size. It would change circumference based on the wearer. So if you had someone who was huge, it would fit them. And if you had a hobbit like Bilbo or Frodo, then it would be smaller. So I don't know, Gollum has some pretty chunky looking fingers there. But I don't know, maybe he ate a lot of fish or something like that, like in the movie. But the problem is so that would change over time. Let's say that the ring is a diameter again of, let's say, 1.5 inches. And if we just wanted to figure out, and that's the diameter, we wanted to figure out what the circumference is, then it's just going to be circumference is equal to pi times the diameter again. So it's just going to be 1.5 times the value of pi. And so that's just going to be, what is it going to be? It's going to be 3.14 times 1.5. So it's going to be about 4.71 inches. And there we're done.